So I do want you to graph these while you're doing them because it's more about reading a graph than like remembering what these shapes are. So, if you don't remember that this is what cosecant looks like, that's not really a big deal. I'm going to draw sine on there real quickly, and then I'm going to erase it just so you kind of remember that these two are related, right? So, sine kind of comes like this. I kind of mess it. But, right, this is kind of the idea. But it should come down like this, sorry. But that's just to help us remember certain things, like where it's crossing the x-axis here. So when we do our domain, it makes sense. So I'm going to get rid of all of these real quick. So again, this is not about whether or not you remember this shape. It's about looking at the graph and answering these questions. So, so the domain and range is what we'll do first. And remember, the domain is the x values. And so, if you remember that cosecant is the same as 1 over sine, right, that kind of gives you an idea where we can't have a 0 down here in the denominator. So whatever values of x give us a 0, when we take the sine of that value and get a 0, that's going to be restricted in our domain. So, what's going on here? Let me erase this for you.
Battery low.
Oh, excuse me.
Power off.
Sorry about that. So anyway, so what we'll look at first here is the domain, and it's all x values except for every time you get to a value of pi. So here at 0, we couldn't use that one because the sine of 0 is 0, the sine of pi is 0, the sine of 2 pi is 0, the sine of 3 pi is 0, and same on the negatives. And so our domain, I'm not really concerned about how you write it right now, but the domain would be, for instance, all reals, but x can't be 0 plus n pi. That's a pretty fancy way of writing it, but all that's saying is 0 doesn't work, plus n has to be an integer, plus any multiple of pi, and those are your vertical asymptotes. Part B is the range. Remember, the range is the y values, and you see here that there's no y values in between -1 and 1. Okay, now they do get all the way to -1 and all the way to 1, so then we're saying that the range is, hopefully this makes sense, but we'll go from -infinity, I did that wrong, sorry. So from -infinity all the way to -1, including -1, that's what that square bracket means, and then from 1 to positive infinity. And that would be our range. The next one is the function periodic, and all that means is it repeating, basically, and that's only going to be for trig functions. And so in this case, part C is yes, it is periodic. Part D, as x approaches infinity. So, what that's asking is, as we keep going in this direction, what exactly is our output going to be? Now, this pattern keeps repeating over and over, right? So this is a kind of a weird one, and the way I'm looking for you to think about it is that as x gets bigger and bigger, right, we're bouncing back and forth between these two things. So actually the function never really approaches anything. The way I worded it is, what is the behavior? Well, the behavior is oscillating, and so there's really no value for that one. And the same for part, E. When we're going out in this direction, again, the value for y keeps oscillating, so it's never approaching a real any one number. And so that's kind of a tricky one compared to some of the rest. So then part F, is the function continuous? No, because you go here and then we have this break, and then it comes down, it comes down here, and then we have another break. and it's up here. And so a continuous function, it's like you can draw it without picking up your pencil. Is the curve smooth? Yes. There's no rigid change of direction, no corners, so all of these make it smooth. Not continuous, but smooth. And again, those are new kind of terms. Most of this is, if you're kind of unsure about it, that's okay. This is just kind of getting you in the mode of looking at a graph. So for the given window, what is f of 0? Okay, so that's our x value is 0. It's actually undefined here, right? Because this would produce a 1 over 0, right? So this is an undefined value. Where is f of x equal to 0? So again, since this is a vertical asymptote, this line will never get to, oops, wait a minute, I'm doing that backwards. So, right, f of x equals 0, sorry about that, is this line, right? And so again, this is undefined because, our range is between -1 and 1, and so we could never get down here to the x-axis. Local minimums and local maximums, okay? All that is just like kind of like the peak or the valley, okay? And so for the most part right now, if you're just eyeballing it, then you're doing pretty good. There are ways that we can go about finding exactly where they are. And just as a side thing, obviously this is Desmos, and if you go to the thing up here, the wrench, you can change the step. And if you just type in pi, it'll give you the step in this, which is very helpful. And I do suggest that you use the Desmos with this. So, like I'll do a couple here, right? X value of pi over 2, y value of 1. So that would be a minimum, right? And so then what you would do is from -3 pi to 3 pi, you would list out, right, this one, and this one for your minimums. Local minimums, and again, that would be pi over 2, comma 1, and then so this one over here would be 5 pi over 2, comma 1, and then the same for the maximums, so this would be part k, right, so negative pi over 2, negative 1 would be a maximum and another maximum, okay? What intervals is the function concave up, okay, and so this one is kind of obnoxious because there's a lot of intervals going on. Let me erase this real quick. So yeah, there's a lot of intervals going on, so I'm not going to list them all out here. But concave up, you just want to think about it as like it could hold water if you poured it into it. So these are all concave ups, and these are concave downs. And again, I don't expect you to know that right now. This is just, a little thought process for you. So concave up would be from -2 pi to -pi. And so a nice way to write that. So you would have to use these rounded brackets because the graph would never reach actually -2 pi here. So that would be a concave up interval, and then you do that for that one and that one. And then a concave down interval would look like, so like this one down here would be -pi to 0. And then again, N and O are fairly obnoxious just because of the fact that you're using this trig stuff. But where is the function increasing? Okay, so just looking at it left to right. I'm going to skip this one down here because my thing here is all in the way. But so like if we start here, starting at -3 pi over 2 all the way to almost pi, that's increasing. So let me get you a couple of those to see. All right, so for instance, again, I'm going to skip one here, but right here is an important point. So starting at -3 pi over 2, if you go to -pi, right, that's increasing. But then when we come down here, right, it's going to be increasing, and then it stops right there. We'd say, well, that's increasing from -pi all the way to -pi over 2. And then we come over here and just repeat it. And so then from pi over 2 to pi. Okay, and those are all the increasing, and then you just flip it around. You know, all the decreasing would be starting here. There's a decreasing, here's a decreasing, this is a decreasing, decreasing. Okay, so I hope that helps. I kind of went through that pretty quick so I can get it uploaded here. Hopefully that makes sense. If not, get back with me, ask me more questions.